How to convert a nonlinear relation to linear that involve fraction? The variable x and y are related by the equation py equal to x cubed minus qx squared y, and p and q are constant. When x over y against 1 over x squared is drawn, the straight line graph is obtained. So this is a nonlinear. I need to change it to linear, which is x over y. But in this case, I see that there's 2y here. So what we do is to bring 2y to both, all the y to one side. So it will be qx squared over y equal to x cubed. Then factorize out the y, you will have p plus qx squared equal to x cubed. And y will be equal to x cubed over p plus qx squared. But since this is x over y, this is only y, what we do is to turn this whole equation upside down. It will be 1 over y equal p plus q over x squared over x cubed. And it is x over y. This is still 1 over y. What we do is to times the equation with x to make it x over y equal p plus q x squared over x squared. And because this is p plus q x squared over x squared, what we can do is to separate this equation. So we will have x over y equal p over x squared plus qx squared over x squared, and this can cut off. At the end of the result, you will have p times 1 over x squared plus q. So in this part, we can say that y here is your x over y, and your x here is your 1 over x squared, since it is drawn by this way. And whatever behind your x is your gradient, and this will be your c. And you also say that the straight line passes through point 0, 2, and 6, 8. So you know that this is passes through y and x equal to 0. It will be your y-intercept. So y-intercept is your q here. And your q here will be equal to 2. And you know your gradient is equal to p. To find gradient, we use y2 minus y1 over x2 minus x1. So we can see that 6 over 6 is equal to 1. So your gradient here is your p. So you find your p and q by substitute the gradient and y-intercept value.